Um, hey everyone, welcome to Tensorflow session. My name is Aditya, a second year ISC student. I am the Android lead at DSCNI. Um, cool, so let's start. Um, I'll actually start with a meme. So, like, if you have not seen this meme before, trust me, you'll see this a lot. Because the thing is, it is quite relatable. So, us freshers, like first year, second year students, tend to these two big words a lot. That is AI and machine learning. But the thing is, we without knowing any basic stuff, like if you look under the hood of what is like inside AI and ML, it's pure mathematics and stuff. So like you should be proficient with computational thinking and DS algo and mathematics and stuff to like build your actual model, machine learning model. And this is where TensorFlow comes into the picture. So TensorFlow is a machine learning library developed by Google, um, where like all the mathematical parts that are there in machine learning and stuff, they are already pre-implemented. So you don't have to worry about how to implement those stuff. All you need to know is what that function does and stuff. So like I'll just give you an example. So, like there's something known as SGD, stochastic gradient descent, and mean squared error in ML. These are two types of functions, optimizer and loss functions. So there are many types of optimizers and loss functions. But for this instance, suppose we want to use stochastic gradient descent in a machine learning model. So like if you are not using TensorFlow and like building your model by yourself, you will have to like implement these formulas yourself. So like even the alpha and theta parts will have to implement. And it's like anywhere between 40 to 50 lines of code. With TensorFlow, it's just one line of code. So this line is from TensorFlow itself. So you want to use SGD, all you need to do is optimize equal to SGD. So this formula is already implemented in the TensorFlow library. All you need to do is call it. So like if you want to know what SGD does, just go and Google it. And like you don't need to know how to implement it and stuff. Same goes with mean square error. So this you might have heard of. So like all you do is you take the actual value, you take the predicted value, you subtract them or vice versa, square it and do this for all the values and then divide it by n. So like you don't have to implement this. All you need to do is loss equal to mean squared. That's it. So this is how TensorFlow helps in developing machine learning models. Um, cool. So let's now talk about coding. So coding has been the bread and butter for us developers since like the dawn of computing, right? Um, so how do we actually solve a particular problem? We take a problem, divide it into sub-problems, and then try to solve it. So suppose you have to develop a stock analysis application, and you have to declare a function which all it does is devise gets price, gets earning, devise price by earning, and returns it. So how do you do it? You define a function, you start with getting the price, the earning, and then do price upon earning and return. So these are rules, right? These are codes you're writing by yourself. Here the data is price and earning. The rules are is this function itself. And on the other side, you get the answer. So regardless of what data you pass it, you'll always return price upon earnings. So you are writing this yourself, right? We human beings are writing this ourselves. I'll just give you another example. Suppose you are developing a brick game. So here also you define what should happen when a ball touches a brick or once, right? So as data, you pass the coordinate of the ball. And then like you say like if the ball touches the brick should disappear. Or like if the ball touches the walls, it should bounce back. Or the slab, it should also bounce back and stuff. So you are declaring this. As data, you pass the coordinate and you write the rules, and based on the rules, it gives you the answer, what to do next. Go to the same line linearly or let a particular block disappear and stuff. So you are writing the rules. So like if you depict this in a diagram, it should look something like this. So you have your traditional programming, You pass it the rules. Rules are being a function in stock analysis application, or what to do next in brick game. The data you pass, price and earning in stock analysis, and coordinates in uh, the brick game. You pass the data and the rules, and on the other side, you get the answer. So, what is price upon earning, or what to do next? This is the traditional program. With machine learning, what you do is we basically switch rules and answers. So, you interchange them. And machine learning's diagram looks something like this. So, instead of passing data and rules, what we do is we pass data and answers, and we let the machine figure out what the rules are, i.e., the function. Um, So, like, I'll just explain. So, suppose you have thousands of images of cats and dogs. Um, is it even possible to write the rules ourselves? Because, like, there could be endless possibilities, right? A cat could be anywhere in the picture. It could have different orientations. It could have different colors and stuff. And this is just about cat. So we can't write the rules ourselves. So what we do is we pass thousands of images and the answers. The answers being this image contains a cat. We pass this as an answer. This image contains a dog. We pass this as an answer, and we tell machine to figure out patterns across all these images. So it figures out the patterns, writes some rules, and then in future, like if we pass another picture which it has not seen ever before, there will still be a probability that it will give you the right answer. So based on the rules that it figured out earlier, it will like tell you is it if it contains a cat or a dog and stuff. So I'll just give an example. So suppose you are developing an activity recognition program. So what it does is it tells that what the user is doing based on the speed of the user. So suppose you start writing the rules yourself. So you do something like if the speed of the user is less than 4, PC is walking. Next up, you say like if the speed of the user is less than 4, but if it is greater than 4, and if it is less than 4, he says walking. If it is greater than 4, he says running. Um, but now you want to update your application to recognize and the user is biking as well. So you again like update your code. You do something like if speed is less than 4, the user is walking. If it is greater than 4 but less than 12, the user is running. If it is greater than 12, he sees biking. Right. Uh, but now suppose the user is playing golf, or you want to update your application to recognize the user is playing golf as well, or if the user is biking. So there could be endless possibilities, right? And also this particular way of writing this application is not efficient. Why? Because not everyone walks with the same speed. Suppose I walk with a speed of 4.2. In that case, this application will be showing that I am running, whereas I am walking. So there's that. So what we can do is we could use machine learning and pass thousands of data of users along with speed and the activity, what the user is doing, and let the machine figure out the rules. And let then like in future, if we pass it any other scenario like any other speed, it'll still there'll still be a probability that the machine predicts the right answer. So yeah, so in this session we'll be learning some about neural networks. So this is how neural network looks like. A neural network, I know it's like really daunting, but like it's just a fancy way of representing functions. So it might be daunting, but like it's easy. Just so think of these neurons as functions. So these circles are neurons, and in a neural network there are neurons. Then the list of neurons, these vertical lines, are called layers, and then this list of layers are called sequence, and the whole thing is called neural network. So there are basically like this layer has 4 neurons, and this whole neural network has like 7 neural networks. So this is what we'll be learning about. So what this basically does is, after training the model, when you pass it your input, on the other side of the neural network, it will give you the answer. So suppose the answer could be 0 or 1 or 2. If it is 0, this will give an output of 1, and these will give an output of 0. I mean, it'll not be exactly one, it will be probability, but still. Um, goes with the other one. So if the answer is one, this will be zero, this will be zero, and this will be close to one or greater than 90%. Or it'll be the probability. Um, cool. So now I want you guys to look at these two sequence and tell me what should be the next value in the sequence, i.e., what should be the value of y for, sorry, what should be the value of y for x equal to 5. And I also want you guys to figure out the equation for which all the x values will satisfy, and I give the correct output of y. Cool. So, um, the next element would be 9. For I for x equal to 5, y should be 9, and the equation is 2x minus 1. So, like, I want to know how you guys figure it out. So, I'll tell you how I figured it out. Like, obviously, when I saw these equations for the first time, I thought like whenever x changes by 1, y changes by 2. So, there must be something like y equal to 2x. But like y equal to 2x doesn't exactly like satisfy these two sequence. So there must be some other constant. So I tried with various values. So I tried like 2x minus 10, let's say. Is it correct? No. So I said, okay, let's say 2x minus 9. Is it correct? No. So then I was like, okay, if 2x minus 1 satisfy, yes, it does. So I was like, okay, cool, this is the answer. So for 2x minus 1, if I input 5, the answer would be 9. Right. If this is how you also thought, like your thought process was, uh, congrats, you just did machine learning in your brain. This is how machine learning works. So it's like for starting, it assumes a random value. So it'll like say, okay, let's assume 5x minus 10 is the answer, right? Then it'll like match the actual answer with the predicted answer. So suppose it has assumed 2x minus 10, right? So for x equal to 1, the answer would be minus 8 or something, or 2x minus 10. Yeah. But the actual answer is 1. So it will take the difference on the actual answer minus the predicted answer. It will take the mod. And in the next iteration, it will try to like reduce the difference. So it will like say, okay, let's now assume like the answer is 2x minus 9. Um, is this correct answer? Okay, the difference is now 2x minus 8 is 7, minus 7. Okay, the difference is reduced. Cool. So it will keep doing this iteration. So it will be 2x minus 8, 2x minus 7, 2x minus 6, and it will keep doing it. And then when it will reach 2x minus 1, it won't ever actually reach 2x minus 1. But let's say it will reach 2x minus 1. At that instance, it will say, okay, this is the answer and this is the rules. So when you pass in future some other values of x, it will give the answer according to that equals to 2x minus 1. This is how machine learning works. I'll repeat again. It assumes a random value, checks the predicted value with the actual answer, and keeps iterating until it's really close to the actual answer. Um, cool. So this is how it will work. Okay, one more thing. Yeah, not. Um, so this is what we'll be building for our Hello World application. So in machine learning also, we'll start with the Hello World application. And this is what the Hello World application looks in machine learning. Um, Instead of us writing the equation 2x minus 1, we'll let machine figure out. So we'll pass the x as our data, we'll pass the y as our answers, and then the machine figure out the rules. And next, then we'll predict the value of y for x equal to 5. Um, the most basic neural network that you could ever build is a neural network with just one neuron and just one layer. So this is what we'll be building for our static application. We'll have just one neuron as an input. We'll have x, y, these the values of x. It'll train itself. Then in future we'll pass it 5 and will give us an output of 9. I mean, not actually 9, but close to 9. Um, Cool. So for this, we'll be using something known as Google Colab. So instead of using a local IDE, we'll be using Google Colab. So Google Colab is an online document where you can write your code, execute it, and share it with anyone. All this you do on a cloud platform. So you don't have to install anything. I'll just show you what I mean. So like if you want to know more about Google Colab, just go and search Google Colab. Sorry, on Google search Google Colab, click on the first link. If you want to know more about, just go on YouTube, search Google Colab, go to TensorFlow channel, and there look for Google Colab. Cool. So go to the first link, click on new notebook. It'll assign you a backend, a cloud backend. Uh, So one really cool thing about Google Colab is like a lot of libraries that we'll be using that like TensorFlow or NumPy or Matplotlib. I'll explain later what these libraries do. But all these libraries, if you are doing this on a personal PC, you will have to install it separately. But with Google Colab, they all come pre-installed. So if you click on connect, it will allocate you a cloud backend. And like if you click on the drop down menu, um, it says something like Python 3 Google Compute Engine backend. And we'll also use a library known as NumPy. So NumPy as well, you'll have to install first. But it comes pre-installed with Google Colab. So I'll just do import NumPy as NP. Um, Doing the same thing here as well, just giving the NumPy library a pseudonym. To execute, okay, so the one cool thing I was talking about Google Colab. So like if you're writing the code in your personal IDE, you have to like write your own application and then you execute it at all at once, right? In Google Colab, you can just write parts of your code and then execute it. So your so like your you don't where was I? Um, Yeah, so I was talking about yeah. So like in Google Colab, you can execute some lines of code, and it what it'll do is so basically, if I click on this play button, it will execute these three lines of code, and the compile like the execution is not over; it has just paused. So whatever code I write next, they'll resume from there. So it's a really way to have interactive coding. Um, so you could to execute this code, you could either click on the play button or click shift enter. It will execute the code and also click create a new field. Um, so now let's start with creating a variable to store our model. So to create a variable in Python, you don't need to use any keyword. Unlike C or JavaScript, even in JavaScript, you need to use the keyword var or val, if I am correct. In C, you use something like int and the name of the variable and then pass the data type to it. But in Python, you just start with the name of the variable. You don't need to like use any keyword. So I'll just do model. So model will be the name of my variable and equal to. So I'll write some code now and then like explain later. So I'll start with keras. Uh, we use the sequential function to create. Okay, I'll explain first. I'll write it. Cool. So I'll just yeah, cool. So what we are doing is so the simplest neural network that you can like possibly create is a neural network with just one neuron and just one layer. So I have a diagram. So this is how our neural network would look like. A normal neural network looks like something like this, but since we are starting with the hello world application, we'll have just one layer and one neuron. So we'll pass our x values to this neuron, and on the other side we get our what called the y values. So a sequence, like I have already told, a group of layers is known as sequence, and a group of neurons is known as layers. So to define a sequence in our neural network, we use the sequential function that's there in the Keras library. And then to the sequential function, we pass a list. So if you don't know about list, okay, I'll have to explain everything. Yeah, so the purpose of list is to store uh, like more than one variable in a single variable. So here we have created a variable named mylist, and inside the list we are storing three strings. So we are basically using one variable to store three strings. Um, so we could have more than one layers, right? So that's why sequential function accepts a list. Even if we have one item in the list, but still it accepts lists. So we have to pass a list only. Inside the list, we define each layer. So each layer one by one. So since we have just one layer, we just do Keras layers dense function we use to define the number of neurons that are there in our neural network. So that's why units equal to one. And input shape means in what shape we'll be passing the data to our neural network. Um, so yeah, I'll just compile it. So like suppose if you have more than one layer, you just separate the layers by comma, and then again do the same thing, keras.layers.dense, and then tell it that how many number of neurons are there in your neural network. Um, cool. So we don't need this to execute it. I'll just click shift enter. Nice. Next up, we'll define something like optimizer and loss functions. So if you remember the second slide. So here we have defined optimizer function and a loss function. So the work of loss function is, so like in our stock and low in our equations, the ML model, we assume that the ML model has taken the random sequence 10x minus 1, right? 10x minus 10, or it was 10x minus 1, and whatever. So in that case, the way of calculating the difference is called loss. So we don't actually use do subtracted value minus the predicted value. What am I talking? Okay, we don't actually do predicted value minus the actual value. We do something like mean squared error. If you might have studied about these. So what you do is you subtract the predicted value minus the actual value, and you square it, and then you do this for all the individual x that are there in our x list, and then you divide it by n. Um, so this is a type of loss function. There are many type of loss functions, but we'll be using mean squared error. Similarly, the function of optimizer is, so whatever loss we have, like suppose it is 9. So loss function will pass that loss value to the optimizers, and its optimizers work is to detect how good it is doing on the model, on the neural network. So it will take the value. So in our case, we said that it goes from 10x to 9x, but why can't it go from 10x to 11x? So its optimizers work to choose what direction should our neural network go in the next iteration. So it passes the loss value to optimizer, and also there are many types of optimizers. SGD is one of them. We'll be using SGD in our first exercise. In our second exercise, we'll be using Adam. So I'll talk about it later. So if you want to know more about SGD, just go and Google it. It's all maths. Um, cool. So what we'll do is we'll do model dot compile. We'll pass it the optimizer equal to SGD, and we'll pass the loss function as mean squared error. I'll just click shift enter and it should compile. Yeah, cool. Now we need our data and answer. So like if the diagram, machine learning diagram, you remember, we pass the data and answers. So we start with creating a list for our x values. Sorry. So we do something like we create a variable for x. Instead of using a simple list, we'll be using NumPy. So why are we not defining and using a simple list? The thing is, in machine learning, like if you remember dot product, product or cross product, we have to do with matrix in mathematics. Um, in machine learning, you have to do that a lot, and it's a lot easier to do that with the NumPy library. So TensorFlow also like accepts the data in NumPy list. So we'll do NumPy dot array. There is a function array which is used to define the lists inside NumPy library. First we pass it a list and then we pass the data type. So in the list we pass our values. So it started with 1, right? Yep, it's -1. So we'll do -1.0 and and then we define the data type as well. So we'll do d type equal to float. Because like we're storing float values in the list. We'll do the same for our answers. Our answers are y. So we'll do ys equal to np dot array. So for -1, it is 2x minus 1 minus 3. Cool. I'll the data type. So we have our data, we have our answers. All we need to do now is train our model. To do that, there is a function in TensorFlow fit, which we'll use. So we'll do model dot fit. Inside here, we'll first pass the data. So our data is X and answers. So we'll do YS, and then we'll tell it to number of epochs. So like if you remember, we went from 10x to 9x to 8x to 7x and stuff. So similarly, we need to tell the model like how many times you want to do this. Like it won't ever actually reach 2x minus 1. The ML model won't ever actually reach 2x minus 1. It will be really close to 2x minus 1. So it will be like 2x, 2.0100001x minus 1, something like that. But it won't ever reach 2x minus 1. So we'll like even if you do it for infinite number of times, it won't ever reach 2x minus 1. So we need to tell it like how many number of times you want to do it. So we define it by using the epochs attribute. So in epochs, let's like do this for 500 times. I'll just accept enter and yeah, it's training now. So it'll do the same thing 500 times. So if you go back to the top, at the starting, the first iteration, we have a loss equal to 0.6377, something like that. Um, as we go ahead, the loss value decreases, so the difference is decreasing. And like on the 500th epoch, it is something like. Also, should I increase the font size or something? Like, is it visible? Yeah, so now we are talking in our loss function is like 10 to the power minus 5, so it's really small. So the lesser this loss value is, the better model we have made. Cool, so our model is trained. Now we want to use it. So we want to use it to predict some value. So to do that, so to print something to your console, there is simple function in Python print. So let's first create a variable that will store the predicted value from our model. So we'll just name it x. To predict a value, there is a function predict in TensorFlow. So we simply do model dot predict. and we pass it the value that we want to predict it for, the x value. So since in our input set we have defined that the input would be a list with just one value, we'll pass a list. So here we'll do something like 5.8. If you click shift enter, it will execute it, and the value is stored in x. Now if you want to print it to the console, you simply do print x. Or if I execute it, it predicts 8.999. So if you remember, the actual answer is 9, but the model has predicted 8.9964. This is what I was talking about. So like even if you train your model for 5,000 epochs, it won't ever reach the value 2x minus 1. It won't ever reach the value. It won't ever predict 9, exact 9. So like I'll just show you, even if I do this for 1,000 epochs, it will still be like 8.99995. So like I'll do it's done. We are talking in the loss value of 10 to the power minus 11. So I'll just execute this again. It will be eight, see, it is 8.999 something 5, but it won't ever be 9. So why is it? First thing, like the first reason is we are training this in with a really low amount of data. So generally, training machine learning model means like having thousands of data. We are talking in a number of thousands. So in the next exercise, we'll use a data which contains 70,000 images, but here we are passing just 5 values for that. Another reason is machine learning deals in probability. So like it will always tell you that like it is 99% sure that this number is close to 9, but it is for because of that 0.0001%, it will say that it could be anything else. So what it is trying to say is like okay, these y's satisfies for these 5 values of x, but what if for x equal to 5 the y is different, though like the different, I mean for us human, like it is easy to see that, but ml will always be confused. So you'll have to take it like if the value is close to 9, you say it is 9. You'll have to write code for that yourself. So cool, so this was our first exercise. If you change the data type to int, the thing is like machine learning works a lot better with floats. You could change it to int, but it works a lot better with floats, so it's a good practice to use floats. um, Also like you'll get lower loss value, that's it. You could use float or something like that. Yeah, so any doubts for this one? I guess not. Also, like the link, I'll just drop it in the chat box. Or later, I'll create a repo on the DSC GitHub channel, and like share the link on Discord if you want. Um, so next we'll be talking about computer vision. So this is the fun part. Um, So computer vision is a field in machine learning which deals with images. So like you pass images to computer, it analyzes it and tells you what are in that image. So suppose you are trying to create a model which detects if in an image there are cars or not. So you train your model with thousands of images of cars, and like the ML model will analyze it and then tell you that if there is a car in the image or not, or like where it is, and it will always also label it. So anything you do with image in machine learning is called computer vision. So like suppose you are developing an application which detects like which detects like whenever you pass an image of a clothing, it should detect that if it is a shoe or if it is a t-shirt or stuff. So like just imagine, is it even possible to do personally, like we writing code for them, because like it's quite impossible, because like all the shoes, or suppose let's take shoes, so all the shoes have different colors, so there are infinite number of designs for shoes, so it's not possible us writing codes for each and every shoe. So what instead we do is we create a machine learning model. We pass thousands of images of shoes and t-shirts to it, and it will train itself. And then in future, whenever it gets a newer image, at least it'll give us a probability that there are 80% chance that this is a shoe, or like there are something like 90% chance that this is a t-shirt, something like that. So this is what we'll be building in our second exercise. We'll be building a machine learning model which detects cloth types. So you pass it image and it will detect like 10 classes of clothing. So to do this, first we need data, right? Machine learning is all about data. The better data you have, the better model you can build. Um, so like there are a lot of data sets available on the internet which you can download and stuff, but like particularly in this situation, there is a data set known as fashion MNIST, which comes like included with TensorFlow. So you don't have to download it and stuff. You don't have to split it. So like if you are doing without TensorFlow, you have to download the data, split it into data and answers like labels, and then split it into training data set and test data set. What training set and test set is, I'll talk later. For now, like there is a dataset Fashion MNIST which contains 70,000 images, which comes pre-installed with TensorFlow. So, like if you want to know more about Fashion MNIST dataset, just go to Google and search. Uh, all the images in this data set, the width and height of the images are 28 by 28 pixel. So and all the images are grayscale image. So you might ask, why not use a data set which contains images with higher resolution? So the thing is, like, the less number of data the model has to process, the better accuracy you will get. So that's why we'll be using really small image. I mean, obviously it should not be too small that all the features get, like all the features disappear. Like all the features should still be visible. So like you could differentiate between pants and t-shirts, right? So that's why. And all the images are grayscale because because it's grayscale, so every image is basically a 2D matrix. So each pixel, and where like each pixel is represented by a number. So because our image is grayscale, each pixel will have a value between 0 and 255, where the number defines the intensity of that pixel. So because it's between 0 and 255, it will take just 1 byte of space. And our image width and height is 28 by 28. So one image will be like approximately 750 bytes. Um, it's 784 bytes. Yep. So every image will be 784 bytes, and since we have 70,000 images, so 7 into 7 is 49. So it's approximately like the whole data set is 50 MB. So you have 70,000 images, which takes a space of just 50 MB. So we'll be using this one only. So there are 70,000 images which are split between two set, training set and test set. So 60,000 images are in training set and 10,000 images are in test set. So why split the data? Why not use all 70,000? Um, so training set is basically used when training our model. So when we are training our model, the data that we pass is the training set. We train our model on those images. So we'll be training our model on the 60,000 images. But uh, we want to make a model which could predict a correct answer for any image, right? In future, like if we give it an image which it has never seen before, even for that image, it should be able to predict the like if it is a shoe or not. For that reason, to actually evaluate how good our model is doing, instead of using the training set, we'll pass it, we'll keep 10,000 images separate, and like after the model is trained, we'll pass those 10,000 images to the model, which then calculate how good it is doing on those images. So it'll take the predicted value and match it with the correct value, and then see how what is the accuracy of our model. Cool. So I'll just create a new Python notebook first. Um, So we'll again start with importing libraries. So we'll be needing TensorFlow, NumPy, Keras, and we'll also need a newer library, Matplotlib. So Matplotlib is used to like plot graphs and images to the console. It's really useful in data science field. So I'll start with importing TensorFlow. I'll do import on the Keras API, and we'll import the what do you call it, NumPy library. So we'll do NumPy as LB. We'll include the matplotlib library as well. So we'll do mat. Um, Matplotlib is a universal library, but we'll be using it with Python code. That's why matplotlib.pyplot. Also, the matplot library as well, you will have to install first on your ID. If you are like doing this on a personal computer, like a local ID. Sorry. So to execute it, I'll just click the play button or set my down. Next up, to load the data that's there in TensorFlow, the fasten mnist data, we'll start with creating a variable. So let's name it fasten mnist. And to load the data, so there are many data sets in Keras, the TensorFlow library, but we'll use fasten mnist. So to do that, we just do Keras dot datasets dot fasten mnist. And that's it. You have the data. This is what you had to do to get the data. Um, Next up, we'll create four variables. First, to store the training images. Second, to store the training labels, the answers. Third, to store the test images. And fourth, to store the test answers. So we'll store it in tuples. So I'll explain what a tuple is. So the lists and tuple are same, but there is one key difference that lists are mutable whereas tuples are immutable. So what this means is like suppose you are creating a list for apple, banana, and cherry. You could after declaring the variable or initializing it, you could further in your code add or delete items from your list. Whereas with tuple you can do that. Once you have declared a list with declared a tuple, you can modify it. You can add something. You can change data of a particular item. So I'll just show you. Wait. So let's just start with creating a list. So we do a comma. So our list A has three characters. I'll print them. So I'll do print A, and I'll now try to modify it. So a list is declared by this kind of variable, and tuple is declared with this. So I'll do A dot append, or let's say so the append function in list basically inserts the past item at the end of the list. So this E will be appended at the end of this list. So I'll again print the list. Um, and I'll do something like I'll try to change the value of first item in the list. So the first item is A, right? Also, all the items in a list are given index, which starts with 0. So first element will have an index 0. The second element will have an index 1. So To get a reference to a particular item, you just pass the index value to this bracket. So I'll pass 0. 0 means the first item. So I'll do like change A0 to D and again print the list. If I click self enter, so we have first a list of three elements. After that, we like inserted element like character E at the end of the list, so it's there. And then we change the first element of the list. Um, cool. But the thing with tuple is like suppose I create a tuple now. I do A. Um, and I'll try to like append, like again try to append any item in the tuple. So I'll do b dot. In fact, there is no function like append for a tuple, so this won't even compile. Mm, So if I try to do this, it will give me an error. So tuple object has no attributes as append. So you can't even do this. So you get a reference to an element, and if you try to change it, it won't compile. So this is the difference between tuple and list. Lists are mutable, tuples are immutable. So our data as well, we will be storing it in a tuple. Because we data we won't be like won't ever be changing further in our code, right? For that reason, we'll use tuple because like even if by accident we try to change a particular value, it will give us error. So it's basically a good practice to use tuple to store what do you call data. So I'll do something like first I'll declare a tuple and I'll do train images and train labels, and I'll do the same for test set. So I'll do test. Um, yeah, to load the data from the fashion MNIST variable, all you need to do is call the variable and call a function known as load data. That's it. So it's this easier with TensorFlow. With like if you are using another like if you're not using TensorFlow, you have to download it and then split it. So the splitting part you have to do personally, like splitting between 60,000 images and 10,000 images. With Fashion Eminence, it's pre like it's already split. So you don't have to worry about what gets stored into the test set and what gets stored into the train set. Cool. We have our data now. Um, so like if you want to see what's there in the train set, I'll simply do okay. I'll use matplotlib bit. I'll do image show. So this is a function is in matplotlib which is used to show the images. So I'll just bring the first image. So the first image in our data set is of a Sue. I mean, it's in grayscale, but Matplotlib prints it in this way. So it's in grayscale. Also, like I wanted to show you like all the images that you have seen like until now, they are basically a 2D matrix. So what I mean by this is, and if you simply do print and pass it the first image, uh, will print a matrix. Okay, wait. I'll change the line width to 200. Yeah, so this image is basically a matrix which has 28 rows and 28 columns. So if the pattern, if you could see, this is the pattern of a soup, and all the other elements, all the other pixels have a value of 0. So since our image is grayscale, all the values are between 1 and 255. That's what I was talking about. So all the pixel will take just 1 byte, and this whole image will take 784 byte. Um, Yep. So also one more thing, like someone asked, like why not use ints? So even here we could go with this. We have int values, but again the thing is machine learning works a lot better with float values and normalized data. So what normalized data means is like if the values passed are between are a float values and in between 0 and 1, it'll like give you a lot better accuracy. So for that reason, suppose like if I divide each and every pixel of this image by 255, it'll all like be between 0 and 1, right? So we'll do that. So what we'll do is we'll do train images equal to train images divided by 255.0. So we are basically dividing each and every pixel by 255. So if so for instance, this pixel has a value 255. So after dividing, it will be 1. It won't affect the image or the ML model if you are wondering like what will happen. I'll do the same thing with the test images as well. So I'll do test images equal to test, or I'll just simply execute it. Cool. So now let's define the architecture of our neural network. Okay, first thing, like if anyone has any doubts, I guess not. So I'll continue. Cool. So next up, we'll define the architecture, the how our neural network looks. So we'll start with this won't be a simple neural network with just one neuron. We'll have multiple neurons. So I'll again write the code and then execute it and then explain it later. So I'll again create a variable to store the model and I'll explain it after writing it. We pass it a list and we do layers. Sorry. Cool. So what we are doing is instead of using dense function as before, we use the flatten function. So what flatten function will do is it will take the 2D matrix and convert it into 1D matrix, i.e. it will have one row and 784 columns, if I'm not wrong. Um, yep. So we'll be passing our data as 1D matrix. So this flattened layer does that. So we don't need to define the number of neurons that should be there in the starting layer. It automatically takes it. Next up, we'll define the mid layer. So this is called as hidden layers. So wait. So yeah, this is the input layer. This layer is created by the flatten function. We don't have to specify the number of neurons. Um, Next up, we'll define the hidden layer. So our hidden layer will have 128 neurons. So we have defined units equal to 128. Um, and it will have an output layer with 10 neurons. So, yep. So one thing new is the activation function. So you could, it's up to you if you want to like give the activation attribute or not. Um, in the hidden layer, what this activation ReLU function is basically doing is, so like whatever is the output of this neuron, so whatever is the output of this neuron, It will, if it is negative, it will change it to 0. If it is positive, it will like pass the same value. Um, so since our output could be always positive, right? That's why we'll be eliminating all the negative values. So that's why we use the ReLU activation function. And next up, we define the output layer. Okay, one thing you might notice is that the output layer and the number of classes that are there in our data set, it's same. So in our data set, we have 10 classes, like 10 different types of clothes. In our neural network as well, we define the output layer as 10 neuron. So this is not a coincidence. Always like the input layer should match the input shape and the output layer should match the output shape. So like we could have 10 different answers, right? So it could be 0 or 1 or 2, something like that, depending on what the image is of. So that's why we use 10 neurons in our output. So 128 neurons, it's completely random. It's experimental. You have to try with different number of neurons, whatever gives the best accuracy. So I'll just execute it. Cool. So we have our neural network now. We do the same thing. We compile our neural network. So we pass the activation function and loss function. So to do that, we do model dot compile. And this time, instead of using SGD, the stochastic gradient descent, we'll use something known as Adam. So if you want to know more about these functions, just go and Google. So it's pure maths. That's why I'm not discussing it because like it'll be too much for first years or something. So I'll do optimizers equal to uh, there is an Adam function. So I'll do tf dot optimizers dot Adam. Um, For the loss function, I'll use, instead of mean square error, we'll be using sparse categorical cross entropy. Um, so it is used when you have more than one class. So we have 10 class. That's why instead of using the mean squared error, we'll be using sparse categorical cross entropy. So I'll do loss equal to and this time we'll also pass it a metric. So by metric, what I mean is if you go to the previous model, while training the model, we had just loss value, right? But this time we want to check the accuracy as well. So to print the accuracy values while training the model, you need to pass metrics. So I'll do metrics, and in metrics you pass a list of attributes that you want to print that while the model is training. So I'll do accuracy. Um, cool, I'll just compile. Hmm, there is a typo or what? What? Hmm, wait, I have one more notebook. Hmm, it's the same. What's the difference? Wait, what? Compiles now. What was the difference? Oh, okay. I used optimizers. Okay, cool, cool. Um, yeah. So we have passed an optimizer. Wait, and okay. I had a typo. Cool. It compiles now. So we have like declared the neural network. We have said what optimizer and what loss function we'll be using. And next up, we'll need to like train the model. We actually train the model. So we use a fit function. So we do model dot fit, and here we pass our data and answer. So our data is train images. So we do train images, and we have train labels. Next up, again, we need to tell it how many times we want to do it. Since we have a lot more data than the previous exercise, let's do it for just 500, like 5 epoch. Cool. So it takes a lot more time than our previous exercise. Like generally, you train your model for like 50, 60 epochs. Um, Yeah, so like in the last exercise we had just loss values, we have accuracy as well now. So accuracy basically means like just multiplied by 100. So at last we have an accuracy of 0.89. So this means is like multiplied by 100 we have 89%. So like out of 100 images you pass to the model, it for 89 of them it predicts the correct answer. Obviously, if you train it for more epochs, it'll the accuracy thing will improve. Um, Cool. So now we have trained our model, but the thing is, we have this accuracy is on the training images. The actual accuracy will be the test images, which the model has not seen ever before. So to do that, there is a function in TensorFlow. We simply do model dot evaluate, um, and we pass the test images and test labels. So we do test, and we simply compile. Um, Yeah, so if you could see, the accuracy on test images has decreased. I mean, not significantly, but yet also the loss value has increased. So this is the actual accuracy that our model is doing. So for 100 images, if 87 times it predicts the correct answer. So, yep, this was okay. One more thing I forgot, like the labels. So the images and labels. So for this image, if it is a Sue, the label is not actually Sue, or the label is a number. So like if I do something like label, I'll print the zeroth element. So it will give me output of 9. Yep. So it's not Sue, it's a number. Why we are using number and not the cloth name instead? The thing is like, first thing, obviously, machine learning models work a lot better with numbers. And second thing is like, if we'll be using strings, we'll be creating a bias. So bias as in, suppose someone in China or something uses the same data set. For them, suppose if they don't know English, they can still figure out that all the Sus are represented by a number 9. That's why. So bias as in, we are not getting biased toward English. So bias is a keyword in machine learning. You'll see this a lot. Yeah, so that's it. So if anyone has doubt or something. Like I thought you guys will be like asking doubts and stuff. That's why it was like 1.5 hour. No one has doubts. Um, Anything?
How is this used in real life?
Yeah, so to use it in real life, you will have to like do Python stuff. So you will have to write code for that. So there are boilerplate codes, just import it, download the image, and so it's complicated with a bit complicated with Google Colab, but you could do it. For that, you'll need to like know Python and stuff. But like if you don't know, you can basically like copy paste that those boilerplate codes, and it'll work fun just now fine. But like yeah, recorded session we'll upload on YouTube soon. Anyways, I started recording late, but okay, we'll like upload it on YouTube.
And the
Also the Flutter. What
link of
what?
Google Colab.
Yeah, link of Google. Acha, okay, for this one. Yep, I'll also drop the link on our Discord channel later. In the next session, if we do it, we'll like actually do the real life implementation. So we'll download an image of a horse. So we'll be building something like a model which differentiates between a horse and a human being. So we'll download images from the internet and pass random images to the model, and it'll give us the value if it is a cat or a dog. So in the next session, we'll be doing it.
When is the next session?
It's not confirmed yet, but we'll let you know soon. Anything else?
About the syntax that you are typing. I mean, you learned it from somewhere. Yeah,
Or TensorFlow or
yeah.
Python? Or
Uh,
Yeah, so the official channel you can go to, TensorFlow. So they post a lot of useful content. But for some, like it'll be too much. So there are free courses on Udacity as well. I'll just show you it. So there are courses by Google itself. So Google and Udacity team. So they have. um, I mean, they won't provide you certificates and stuff. Also, a lot of courses are there on Coursera. So there is a course by Lawrence and Andrew NG, if you know him. So if you go to catalog, just search whatever you want to learn, and from the filters, select free courses. So the first one is in collaboration with. So this is TensorFlow Lite. TensorFlow Lite is a different thing. If you want to learn about TensorFlow, just go and enroll in this. It is free. Anything else? Anything? You'll find those video on YouTube channel. Yeah. Anything like you could ask anything. It doesn't have to be. I mean, obviously related to machine learning. Okay, one more thing, like a lot of people will tell you that for machine learning, you need to know mathematics. Obviously, it's good to know, but like I started. I wanted to get into machine learning, so I had no idea where to start. So like I went to this Udacity thing and took the course, and then later I got to know that okay, first you have to start with mathematics, and then you should go to TensorFlow. But instead, I enjoy doing this way. So you learn TensorFlow, whatever activity, like whatever function you want to know about, just go to Google, go to Google and like search about them. That's it. So this way you will be coding as well as learning. This is what I prefer. I don't know about you guys.
How much time did it consume
For what?
to learn
Um,
ML?
Dude, the thing is, you can't learn ML like it'll take time, obviously. But even though if you spend like, if I am not good in ML at all, so it'll take time, obviously. Like basics, you could do in a month or two, but then machine learning is really vast. And when you get into the mathematics part and stuff, it's big. It's quite big. So like this Udacity course says that it'll take 2 months, and this is just this starting. This is intro to TensorFlow for deep learning. Like if you are interested, Flutter will also upload soon. Like we'll upload it.
Bro, what the courses about Udemy? Who is the quality of?
I have not personally tried them, but I don't know. Like I can't comment on it. Like cause like I've not tried it. I've tried Coursera or edX or the Udacity thing. Udemy, I don't know about. Cool. So bye guys, this is it. Let's meet in the next session.
Thank you.
Yeah, cool, cool. Bye.